Question 15. Find the equation of the plane through 1, 0, minus 2 and perpendicular to each of the plane 2x plus y minus z minus 2 equal to 0 and x minus y minus z minus 3 equal to 0. So I have already drawn two figures to explain this question better. So these, in the first figure, as you can see, there is two intersecting planes. So say the blue one represent the first plane and green one represent the second plane here. So we need to find a third plane which is perpendicular to both these planes. So in the second picture, as you can see, the red plane is one such plane which is perpendicular to both green and blue planes. So why is we can easily show that. So say if you see the normal to the plane, normal to the red plane will be something like this, right? It will be something like this, and this normal is parallel to this plane, and this plane, as it lies, this normal lies on the two planes. So since the normal lies on these two planes, so we can say that these two planes, this normal is parallel to this plane and this plane, uh, having which essentially means this plane is perpendicular to the these two planes are perpendicular to the red plane. So this is not needed in solving the question, so I am just giving you an example how this problem looks visually. So we are given two intersecting planes and we are asked to find a third plane which is perpendicular to the given planes. So we need not draw these figures. We can directly go and solve using the concepts we have studied before. So let me just so I will just note down the equations given. 2x plus y minus z minus 2 is our first equation. 2x sorry 2x plus y minus z minus 2. 2x plus y minus z minus 2 equal to 0. This is our first equation. Then x minus y minus z minus 3. X minus y minus z minus 3 equal to 0 is our second equation. And the given point is 1, 0, minus 2. So 1, 0, minus 2. These are the information given. We don't need any other information. We just need this much information to solve the. Say our required plane is in the form ax plus by plus cx is equal to plus d equal to 0. So let's write a general equation. By plus cz plus d equal to 0 be our required equation. Now we know that this equation is perpendicular to 1 and 2. So plane 3 perpendicular to 1, from that we can write these the direction cosines of plane 1 of the normals of the plane 1 and multiplied with the direction cosines of the normal of the plane 3 will be 0. As you know, I'll just that plus d1 equal to 0, a2x plus b2y plus c that d2 equal to 0. You have two planes like this, and if these two planes are perpendicular, from the concept of angle between the two planes, we can say that cos theta is equal to 0 for a1 a1b. So we will be using this information here. So if you don't remember this, please go and refer the concept angle between the planes. I have done that video before in this channel. Please refer that video. So we will be using this concept here. So which means 2 into a plus 1 into b plus b minus 1 into c minus c equal to 0. And 3 is perpendicular to 2 implies 1 into A minus 1 into B minus 1 into C. Again minus C is equal to. Now we have to find ABC from these two equations. We can do in one shot like this: A minus 1 minus 1 minus positive 1. So minus 1 equal to B A B minus 1 minus minus 1 again. Sorry, minus 1 minus minus 2 equal to 2 minus 2 minus A by minus 2 equal to B by. So we have our direction ratios here. So we can just apply it to the equation. It's called using 4 3 get minus 2A, sorry, minus 2x plus y minus 3z plus d equal to. Now we know 1 0 minus 2 pass through this plane. So pass through 5. That implies minus 2 plus 0 minus 3 into minus 2. Minus 3 into minus 2 is 6. Positive 6 plus d equal to 0. Or we have that implies d is equal to minus 4. The equation is using using 5 and we have. So we will just multiply to make this term, or we just write or you multiply throughout by minus. The required equation 2x minus y plus 3z plus 4 equal to 0. So as you can see, if we know the concepts, we don't need to draw anything or just can apply this. So if you see the angle between what am I using here, the direction ratio, if you see the direction ratios of normal of the required plane, direction ratio of the normal to the plane here is ABC, and we know that this normal to the first plane, direction ratio of the normal to the first plane is perpendicular. These two are perpendicular. If you draw a perpendicular to the first plane, it will be like this. That direction ratio is 2 1 minus 1. Similarly, if you draw a perpendicular to the two plane, it will be like this. Will be the direction ratios will be minus 1. So we know that these three lines are perpendicular to each other. So we can just use the concept angle between the vectors or angle between the plane directly. So that is what we have done here. I have given a picture just to make it clear what we are doing. So these are the steps. I hope this is clear. You have it's better if you remember this equation, so you don't have, you can directly apply it and solve it in steps. These are the steps. So before moving on, if you are not familiar how I found out this, you could just eliminate each option in terms of a and find out the ratio also. So you don't have to do this, but what I have done is, for a you take this to this minus this, for b this term into this term into this, for c term into this. So this is what usually in metrics, solving linear equations, um, and solving such three variable two equations, we usually do third. If you are not familiar with this method, do comment. I will try to make it on it. Guys, these are the steps to solve this question. So solution to question number